Hi, welcome back to the breadboard, and today we're going to look at something a little different. If you get one of those days when you go to do a job and you want a little cutter using your Dremel, battery powered, you turn it on and absolutely nothing. So you slam the battery in the charger, wait a little while, and still absolutely nothing. So what I have here is a Dremel 10.8 volt lithium-ion battery pack, and basically one of the packs has failed. So I have another one here which is still fine. I keep these out in the garage normally, so they do get cold on occasion. If I put this one in, you can hear works just fine. This one that's been on the charger doesn't want to do squat. So we're going to have a look at what's wrong with the battery pack and how we can fix it, if we can fix it. Alright, so let's get to the bench, have a closer look, and we'll see what we can find. So here's the two standard battery packs. I've got a meter, the motor section, we don't need that for the moment. And this is the standard charger for the Dremels. So when I put the batteries in the charger, of course, a good one will normally light. See, this one is flickering and then the light goes off. That's the bad one. And a good one, when I put it in, see the light comes on nice and steady, and it will stay on until the battery's charged. I don't know if you can see that very well, but got the light on there. Okay, and with the bad one, no light whatsoever. So let's investigate what's going on here. So that's the bad one, this is the good one. Zoom out a little bit, just so you can see everything. Let's put a meter here so you can see that as well, for any voltages we happen to measure. Alright, let's get this turned on. Okay, so these are normally 10.8 volts, so there's probably going to be 3 lithium cells here of 4 volts each. So with no load, just having been charged, it probably should be around 4, 8, 12 or 13, well 12.5 volts or so. The top of the packs are marked clearly plus and minus. This side has an extra tab on. I suspect that that's for a thermistor or something like that to make sure it's not getting too hot. So let's just stick the temperature DMM on here and see what we get. So this is the good one, and helps if I connect it the right way around. And as I said, we've got just over 12 volts, so 12.32, and they're basically 4.2 volt cells. Now I haven't fully charged this one yet, which is probably why it's a little on the low side. So that battery is a good pack. Now let's take the other one and see what voltage, if any, this one is reading. And you can see here it really isn't reading anything. It's just, that's just pick up. Right, I can stick it on the top, and next to that there's no real voltage there at all. So either one of the cells or more than one of the cells inside this thing is gone. So let's open it up and have a look at what kind of batteries are in it. I suspect that this will just be able to push these in, and there are some tabs here that I've already had to go at this once to open it, so I know how to open it. But basically the trick is with batteries is look for where there are telltale signs of how you get in. So with this one, where I haven't had it apart yet, you can see that there are some tabs, little gaps here, so you have to carefully look around for how it might come apart. And so with this one, I've already done that once before, and these blue plastic tabs are part of the base here, so you have to push them in and underneath. And there are also some little tabs into the base here, which normally you would push in as well. I actually managed to break one of them while I was trying to discover how to do this. And sometimes you just need a little bit of extra leverage to get the tabs out properly. Like that, and you just slide that off. So that's all there is to that. And basically, yeah, see, that's why this is not sitting properly. I broke 2 of the tabs. Now I know how it is. I can do it. But anyway, that's it. That's the cell. So we take that out, and as you can see here, basically it's just 3 cells taped together. And yeah, there is a thermistor, I think, here by the look of this. See if we can undo a bit of the tape. Yeah, just going to take this tape off anyway because we need to Probably going to have to replace one of these battery cells. I'll keep it to reuse. So there's the thermistor. We got 1, 2, 3 cells, and they're just in series. So that makes up our battery pack, and these are Samsung 076 battery. So we'll have a look in a moment on the internet and figure out what capacity they are and things like that. But let's just take the tape off of these for the moment. So that's the thermistor. See, battery packs like this are very expensive, so if it's possible to repair them rather than just take them to a recycle center and dump them and spend, you know, $70 buying another one, then that would be a good thing. So you can see here now how this is constructed. Pretty easy. Just a few metal welded bits on here down to the base, and little bits of bent metal to make the contacts when the thing is plugged into it. So let's measure the packs and find out if there's one or more faulty ones. So let's just do the top pack first, plus and minus. So that pack is reading 0. Now we'll measure this pack. That's reading not a lot either. And this pack is also not reading much now. So these are all very, very flat indeed, which means they're probably no good. I doubt they would recover during charging. But what I'll do is I'll just quickly power up my power supply, and we'll see if we can put any current through them, and maybe they might recover a little bit. Okay, just found some longer leads. So right now the battery is charging up rapidly, and if we stick the meter on here now, you can see there that it's rapidly collecting a voltage. So that may well charge up quite nicely on that cell. Let's just test one of the other cells now. So this cell here is not taking, on the right hand side, is not taking any current whatsoever from the power supply. Now let's just test the last one. And that one is taking the full current from the power supply as well. So potentially we've got 2 good batteries here and 1 bad one. And you can see that that one's rapidly accumulating a charge as well. So I'm going to see what batteries I've got, and if I have one that's exactly the same type as this, we'll just switch the one out, and if not, what we'll do is we'll make up a new pack of 3, and we'll just use these 2 individual ones for some other projects or something like that. So let me just dig out my batteries, and we'll see what we can do with it. And by the way, I guess one of the questions is, where do you get batteries from to do a repair like this? Well, the answer is your local hardware store that does recycling. If you can, when you go in there, ask them if you can have some of the recycled batteries, and when you open them up, you can find the good cells and take them out and keep them for repairing old cells. So in this case, I'm going to replace this one battery, if I have it, this one, with a good cell. So let's dig out my batteries and see what we've got. So I was in the fortunate position a while back to be working with a company where everybody in the company was issued laptops, and you're talking about thousands and thousands of employees, and the fact that they had all issued laptops. They did not use desktops hardly at all in the company. So I managed to make contact with the IT department, and they gave me quite a handful of old laptop batteries that I could use to recycle the batteries. And as you can see here, all of these batteries that are in here are all from laptops, except for these few here. These are flat ones from cell phones and things. They all still have what seems to be a reasonably good charge. It's just that it's not worth the IT department figuring out time-wise whether the battery is good or bad. They get the users come in, they complain that it's not staying charged up properly, and a lot of the times it's because they've just been abusing them, not letting them charge up. People tend to not understand really how to use rechargeable lithium batteries. They don't let them balance and things like that, and as you can see, most of these are actually paralleled still. So what I've done is, where they were paralleled, I've kept them in parallel so I know that they're match pairs, because if I wanted to use something with twice the capacity, that's effectively a 3.2 volt lithium-ion battery, and it's got twice the capacity of one cell. And these are, quite reasonably good capacity. You're going to get about 3 or 4 amps out of these just at 1C. So as you can see, I got a lot of them to make up for projects. A lot of them are different companies. Like this one is, I think, LG. You've got a bunch of Samsungs here. Different colored Samsungs to this one, of course, and some other. These are green sleeves, but they're not these ones. These were clearly marked Samsung. I'm not sure what make these ones are. They're probably LG because of the starting code or something, but who knows. Anyway, it doesn't look like I have an exact match for the batteries that are there. So what I will do is, I've got if I have 3 of the green ones, which I don't. No, so I'll probably just take a couple of packs apart, and or maybe I might just use one of these. I'm going to look up the part number for the ones that we're going to replace, and then I'll look up the part numbers for these, and we'll see what the capacities are on them. So let me just come right back. Okay, so I've done a bit of checking, and the battery packs, these don't have the protection built into them. They're built into either the charger, or they're built into the tool itself to cut the voltage off before they discharge them too much. So, but the batteries that I have, I actually don't have any other INRs. I did a check, and these are rechargeable lithium nickel batteries, rating about 1.3 ampere hour. And the ones I have, the other Samsungs, are lithium cobalt, so they have a higher capacity, about 2,600, so about twice the capacity, but they are a slightly different chemistry, and I'm not going to mix chemistries in the same battery packs. Now I do have other ones here, but they're also ICR, which are the cobalt ones. These all came out of laptop battery packs of various kinds, so they're typically all the cobalt because they have the higher discharge rates, and they're often paired like the ones you see here, and they're used for the high capacity because of what laptops require to run all the CPUs in them and things. So I'm not surprised that they're the ICR kind with the cobalt. But that doesn't mean we can't use them. It just means that we'll replace the entire pack with 3 of the cobalt batteries instead. The voltages in the specifications for discharge cutoff and charging cutoff is exactly the same. It'll just take a little longer for the battery pack to charge, and that's fine, especially if it's going to give me twice the duration for the running. So that's what I will do. I'll replace all 3 of them with the ICR 26C batteries that I have here. I just want to put them on a charger, make sure, because they've been sitting in this box for a little while, so I just want to make sure that they'll hold a charge easily, and make sure they haven't died. I put a little bit of a charge in all of these, which is the way you're supposed to store them, so they should be okay. Anyway, I've taken some out and we'll have a look. So these are the ones I pulled out. These green ones are from LG. I don't know what their chemistry is yet. I haven't looked up the specifications, but I obviously have used these in the past because I can see where I've soldered some wires on them just when I was playing with them. As you can see on the DMM there, they're all 3.7, 4, 4, 4. So they're all holding a good charge. So what I'm going to do is, even though these ones are the same color, they're actually a completely different manufacturer. These are LG, whereas these are Samsung. So I'm actually going to stay with Samsung, and I'm going to put these other ones in. I'm pretty sure these are high capacity, 2.8 or 3 ampere hour as well. So it really doesn't make any difference. So I'm just going to use these ones. Now, when you're messing with these, you know, when you look at these, you can see that they're welded on. Now I'm going to have to solder them on because I don't have a spot welder. When you solder these, you really don't want to get these batteries too hot, so you want to make sure you have a powerful soldering iron so that you can get that soldered on really, really quickly, or leave those connections connected and actually cut the tabs a little bit away, because this metal that they use to spot weld between them will solder very, very easily. So if you take the tabs apart and leave a little bit of extra, you can actually solder onto them rather than trying to solder onto the cap of the battery, which is much better way to do it if you can. All right, at a push you can solder onto the battery. You know, these, you can see on the bottom of this one where I actually, when I took it off, you can see it left little pimple marks on it, which is not very good. You can file that smooth. There's no holes there, it's just a little bit of stuff on the top, so a little bit of file will take that off. But if you can, as I say, if you can leverage the tabs that are already soldered on, then that's a better way of doing it. We need to pull this pack apart, make up 3, and figure out where to cut these. So when I'm comparing to these, the batteries are the exact same size. You can see that if I cut these right down the middle, and then when I cut this close to the battery pack, I'll have enough to be able to solder on still on the tab. So I'll just replace one battery at a time. Now, a tip for cutting these apart, by the way, especially when they typically are still carrying a charge, is don't cut the positive end apart first, because that is too easy to break through the insulation and make a short with your pliers. And don't ask me how I know that, but I do. And either your pliers will get very hot very quickly, or the metal strips will get very hot because you'll pass a lot of current because you're shorting them out. But if you approach on the negative side first, then you can cut through this, and even if you did manage to break through the insulation, you're only shorting itself to itself, so you're not going to get a high current coming through there. You don't actually want to break the insulation if you can help it, only because, you know, you want to maintain the integrity of this. But you can always put an extra piece of heat shrink or tape around them if you have to, once you're done. Because, you know, sometimes when you're cutting them out of the battery packs and things like that, out of the laptop packs, you do occasionally get the plastic sleeving splitting and things like that. So just be aware. The other thing to be aware of when you've got these apart is these edges are going to be very, very sharp. And then once you've done the first part and you've got them apart, now you have an easy access to the positive end where you can, you know, where there's a risk of shorting to this now. So you know, having it apart, you completely eliminate that risk. So I'm just going to cut this side of here so we have a bit of a long tab. Now obviously if you're using a pack that is just multiples in series, so one of the smaller laptop packs, then you're not going to get this issue about having to cut multiple packs apart. All the ones I have been using, they were from battery packs that were paralleled up to get the extra capacity. So there we go, there's the 2 batteries apart. Now I'm just going to do the other one, and we'll get to soldering the packs together, and I'll just clean up the connections on the end. Okay, so this is basically what we're going to do. We've got a metal tab on this side to solder onto this end of the battery. We've got a short piece of metal to solder onto this end. Join the 2 batteries in the middle here. And I'm going to do these soldering first, and then I'll put this one on. And then we will disconnect these off the end of the cap here and solder the new ones into the cap to complete the wiring. And then that should be it. So what I'll do is I'll bend these up and cut them off, and then solder them, and then push them back through and bend them back down again when we're done. So I'm just putting the battery in a clamp so that I can solder a little easier. I'm just wetting this side of it right now, and then I'm going to take the little piece of metal and I'm going to wet that side of it. And remember, this one is coming up, so it needs to be connected like that. So I'm just going to hold it with a pair of pliers and sweat the other side of this. That way when I bring them together, it will solder nicely and strongly like that. Yep, nice and strong. And of course it cools down rather rapidly because of the mass of the battery. So that's one done. This is just a little Dremel, so it's not going to be consuming a huge amount of power. And make sure I get these the right way around, of course. I got positive coming up, positive coming across. So that's going to be here. This one's going to be here. Going to be kind of like that. So let's get this one done next. So same procedure. Sweat down the top of here first, and now we'll join them together. So that's another one done. Now the fun starts, because now we're going to assemble the battery on the top. So this is negative, we want to go to a positive. Now, as I said before, if you don't know what you're on many other videos, if you're not sure what you're doing and you're not experienced with this, then seek help from somebody that is. Now, one of the things I'm paying attention to here is a lot of these batteries have the little paper wash around. That provides an extra bit of protection, and I'm actually leaving that on because it will help to keep these insulated even after the heat of the battery soldering. So that's all a good thing to do. I know. Solidly on, I hope. Yep. Now remember, I'm using the tabs to solder these on with, too, not the and this last one's going to go this way. Now the solder I'm using has got flux built in, so that's hence all the smoke that you're seeing. Now this one we need to, I think, turn around a little bit. So what I'm going to do is assemble these together. And get that last one connected. Now, that's our basic pack, which will slide into here once we're done, like that. Okay, so what is the best way of doing this? Probably to unsolder the PTC first. Temperature sensor. That way I can unfold these. Ouch, still hot. To remove the battery. So cut that off as close as we can to the positive terminal, and then we have a, well, close to the edge of it. So that will leave a little bit on there. Now I actually do want to make sure I get this the right way. So positive is over this side. So it's going to come down here when it comes out. So this is going to sit on like this. So I need this. See, it doesn't quite reach. Okay, so what I've done right now is I've just unsoldered the bottom temporarily, and I've rotated these two batteries so that they're basically aligning with where I want them to be within these tabs, and I'm just going to solder them straight through. I might melt a little bit of the plastic, but now that I've got this clamped, I'm just going to pull this off and tin these first, and then I'll solder them, sweat them together with it on. That way they will be exactly in the right place. That's those ready, and these are ready. So we'll just drop this one on. The temperature probe goes next to the negative side, so that's the extra connection here, and you can verify that by seeing there's 3 connections on this side. I need 2 on this side of this. So this one, which is my negative, is going to drop in here, and then I'm going to sweat it straight on the top of there, and then the positive will be on the other side. So I'm going to use my screwdriver to hold it in place and apply a little bit of downward pressure while I just heat it. Watch it melt on, and then just let it cool like that. Perfect. Now we'll do the same with the other side. That takes care of that. Now we can solder the, well, we can tape it, and then we can solder the PTC back in place. Now we have to figure out how to get the top battery back on here. So looking at this, we need this positive tab to come out to about here. So we have just enough to solder, but we're going to have to solder directly onto the cap. It's just about how all of these things are lining up. So even no matter how we cut the packs, that would have been the same. So we need to just trim this off from here so we don't have any chance of shorting in the middle. And we'll just do that carefully because this is a live pack now. Just put a piece of insulation over there so I don't accidentally short it out. That wouldn't be good. And this one's actually close enough that we don't have to worry about it. Now I'm going to sweat a little bit of solder carefully right on the edge of here so that I can get that onto it. I don't think I have any bits of metal. I mean, I could use just regular wire, but it isn't going to be very flat, so I would prefer to use the salvage connection. So that's what I'll do. As I said, use a powerful soldering iron. This is a high-powered Weller temperature-controlled iron, and it can deliver a lot of heat very quickly. So I can actually get this hot and soldered without heating the battery up too much. Now be careful here you don't let any solder drop down there, because that would be rather disastrous and an instant short on the battery. So be very careful and have a means to put it out. I have a fire extinguisher nearby and a kitchen, so I can dump it in some water if I had to. Okay, that's that one. On this side I still do have a little bit of a tab left, so I can solder onto that nice and easily. And then this tab will go right in here. Like that for that battery. So now we're able to get this battery, make sure I put it in the right way, negative, positive, negative, so it goes in this way. So I'll get one end done at a time. Keep it over the top of the battery. Now we just have to solder this end in with a little bit of help from a screwdriver just to push it on once I've heated it up, and it'll help it cool down quickly as well. Okay, that's solidly on. solidly on and back together. So theoretically now, if I measure this, I should have 4, 8, 12 odd volts on the DMM. And negative, positive. 12.1. So that's exactly what we need. So let's get this thing re-put back together and stick it on the charger and see if it works. It will take a little longer to charge, but that's expected. Let's put some of this tape back on just to hold it together and still. That's right back in the pack. Put the top back on it. I may have to put a little bit of glue or tape or something on there because I broke the tab when I took it apart. But anyway, theoretically now, I should be able to put it in here and taking a charge. So let's just leave that alone for a while. I'll keep an eye on it. It's got the thermistor there and everything else, so in a couple of hours that should be nicely charged up. So there we have it. A few hours later, the battery charge light has gone off, and bring the meter into view. We just take this out just to prove it is not faulty still. Unplug it and plug it in, the light comes back on. So let's see how many volts it's gone up to. Should be about 12.6, 12.8, something like that. So I've taken it off the charge, so it's no longer being charged. So it's dropped just a little bit, so it's 12.4. So each cell is about 4.1 volts, which is just perfect. So that's no load, of course. So that shows that it's working in there, and it did fully charge up and cut off. So now let's just put it in the reeds full, and it will probably last twice as long because they're double the capacity batteries. So there you have it. Quick repair of a battery pack for a Dremel 10.8 volt lithium-ion battery, lithium-ion little utility tool. So as I say, the batteries are quite expensive, and that's it fixed. So we went from well, these claim 1 amp per hour, but the batteries inside it are actually 1.3s. I think the other one was the same. Oh, actually these battery packs are slightly different. This one is 1 amp per hour, this one's 1.3. Anyway, both 10.8 volts, so they're obviously slightly higher than that when they're under no load. And we're good to go. So anyway, if you like that, thumbs up. If you don't, then don't. But either way, it's done, and I hope you learned something from that. Word of warning, again, lithium batteries are dangerous to use if you don't know what you're doing. Treat them with care. Don't overheat them. And don't use them in circuits where they're not protected, because you can end up with fire, explosions, etc., etc. Be careful not to puncture them, and if you don't know what you're doing and you're not experienced with this stuff, then don't, seek some help. But a lot of these battery packs for various tools are expensive, and if you can repair them yourself using another battery pack, taking the cells out of it, then that's great. Now, things to remember though, don't mix chemistries. You noted that even though I only had one cell failed, I didn't have any of the lithium nickel batteries, which were in the original one. So I replaced all of them with nickel chrome. And I kept them all from the same manufacturer as well, the ones that I put in, so they're all Samsung. So you probably could mix manufacturers, but if you really want to be as safe as you can, Stick to the same manufacturer, stick to the same chemistry and the same capacity batteries, and if you can even more, stick to batteries that are from the same batch as well, because then they'll be the same age and everything else. I'm not 100% sure if my batteries were all from the same batch, but I'm pretty sure they were. Sorry, from the same battery pack. That's the easiest way when you're taking apart old battery packs and things to recover the batteries. To keep the good ones, obviously dispose correctly of the bad ones. But try and keep them from the same batch of batteries from the same device that they came out of as well. That way they're all sitting about the same age, and they're going to give you more life. They should wear out together. Anyway, that's about it. So yeah, main thing, same manufacturer, same chemistry, same capacity. Keep them that way.